Here is your assignment from yesterday. For those of you who were not here, go ahead and write this assignment down, and you'll probably want to get with somebody who was here yesterday to copy down those notes. There were some constructions that we did in class, so you will probably need a compass. But those of you that don't have this homework assignment finished, go ahead and keep it so you can finish it tonight, since I'm not here to go over questions. But if you are finished with it, you can go ahead and turn it into the box. Make sure your name is on it, fold it. So if you need to pause the video for a second to turn in homework, go ahead and do that. Also, you should have, Mrs. Stokes should have a stack of notes to hand out to you guys for section 3-6. Today's notes does not come out of our workbook. It's something that was created here. So again, if you need to pause the video to pass out those, go ahead and do that. All right, so today is another lesson that's pretty much straight out from Algebra 1. It's talking about writing equations of lines, and we're also going to review graphing lines. Now, I know some of you guys are not huge fans of algebra. You're doing better in geometry, you like geometry better. Others of you, it's the reverse. You guys remember your algebra really well and you like that. Well, today is for those algebra people. Those of you who are not algebra people, I still hope you remember some of this. So writing an equation in slope-intercept form, we've actually already talked about this a little bit so far, is in y equals mx plus b, where m is the slope and b is the y-intercept. Point slope form is probably something you're less familiar with. Maybe some of you still remember this, but probably less of you do. Point slope form, you need the slope, which again is m, and the x1, y1 come from a point. Okay, so you could plug in the x value here, plug the y value in over here, but notice that it says minus. So you got to be careful. If x1, let's say, would be negative, minus a negative would turn it into positive. So we need to be watching for that. Vertical and horizontal lines, though, are a little bit different, especially vertical. Vertical lines have equations of the form x equals a, where a is the x-intercept, and y is for horizontal lines. So horizontal lines are of the form y equals b, where b is the y-intercept. Now I tell this dumb little story to help remember the equations of vertical and horizontal lines. And if those of you who've been in my class before, you've probably heard this story. Again, I apologize. My artwork is not very good, but I do the best I can. So when I think of equations for vertical and horizontal lines, I think about skiing. So to start with the y, horizontal line looks like this. You know, and if there's this guy skiing, so here's the guy's skis. He's going to be pretty bored because skiing on a horizontal line would be boring. There's no slope to it at all. So why would you want to ski on a horizontal line? It'd be boring, right? Boom, boom. So y would be horizontal. Now x, this one's a little bit more interesting. So pretend this some dude, this not very intelligent fellow, is skiing down, oops, can't really see this guy's head, skiing down a vertical slope. Well, what's going to happen is he's going to fall down and he's going to die. He's going to go splat. Okay, so let's pretend he hit the ground. And when somebody dies in cartoons, they have X's over their eyes. So X equals a number are equations for vertical lines. Y equals a number are the equations for horizontal lines. I know it's a dumb story, but it works for me. The point slope form of a line that we talked about up here, okay, where I told you, you know, point, slope, and all of that. I can derive it from the slope formula. We've worked with this before. So let's say, okay, we've got 2 points, x1, y1, x2, y2. But let's use x and y, just a general point, as x2, y2. So I'm going to start with that. So I'm going to replace y2 with y and x2 with x. And to put this in point slope form, first thing I'll do is I'll multiply both sides by x minus x1. Cancel that out on the right side. And over here on the left, I'm going to switch things up a little bit and put m on the left side, but that's okay. Still equal. And if you notice, this looks pretty much the exact same as what's above here, except y minus y1 is first. So to make it look exactly the same, I'll just switch the places of these two things, which is fine. Doesn't matter if I switch sides of the equal sign if both parts are moving. And then voila, there we go, point slope. Ta-da! Okay. I like point slope form because if you have a point and a slope, all you have to do is plug it in. So with example 2, if I'm writing the equation of a line, I'm told the slope is 3, so that would be m. And I'm told a point, that would be x1, y1. And I'm asked to put it in point slope form. All I do is plug it in. So 3 would go in for m. 2 would go in for x1. 1 would go in for y1. And then I just write my answer. So it'd be y minus 1 equals 3 times x minus 3. And I'm done. So this was just plug the numbers in, you got it. Nothing really else to do. But for B, if I want to write this in slope-intercept form again is y equals mx plus b. So I need slope and y-intercept, hence the name slope-intercept form. So in order to find slope, I'm going to need to do the slope formula, y2 minus y1. So sometimes it helps to put x1, y1, x2, y2 underneath your points so you don't get lost. This would be 2 minus 4 over negative 1 minus 0. 2 minus 4 is negative 2. This is positive 2. So that's your slope m. Now to find the y-intercept, you're going to need to use a point. So let's say I pick this point right here. Now some of you might be noticing that that point 0, 4 is a special point. That actually is the y-intercept. That's where the graph crosses the y-axis. But I'm going to show you why. So if I put 0 in for x, 4 in for y, and 2 in for m, the only variable I'm missing is b. And I need that in order to write my equation. So this would be 4 equals 2 times 0 plus b. Well, what's 2 times 0? 2 times 0 is 0. So the y-intercept, b, equals 4. Well, look at this point. The point was 0, 4. So I really didn't need to plug this point in, but probably a lot of you would miss the fact that the point 0, 4 is actually the y-intercept. So my answer here would be y equals 2x plus 4. So I calculated the slope using the slope formula, and then I had to use the slope and a point, plugged it in for y, m, and x, and then found b. Last one. Line with an x-intercept of 2 and a y-intercept of 3 in point slope form. X-intercept of 2. In order to do this, I need to remember what the coordinates would be of an x-intercept of 2. So if you think about xy axis. X-intercept is where the line crosses the x-axis. So in this case, it's where x is 2. That's the point 2, 0. And a y-intercept of 3, okay, the line that I drew here doesn't have a y-intercept of 3. Let's say I did. I drew a line with a y-intercept of 3. The ordered pair for that would be 0, 3. So I'm going to write it in point-slope form. Well, I need to figure out slope, because with point-slope form, I need a point, and I need slope. So I'm going to figure out slope first. That would be doing y2, which is 3, minus y1, over x2 minus x1. So my slope is negative 3 over 2. And then I just pick a point. It doesn't really matter which one I use. Let's say I use this one. So point slope form again looks like this. So y is just y. 0 would go in for y1. My slope is negative 3 over 2. And my x1 would be 2. So that's my answer. Pretty simple. But sometimes we might have to calculate something first. Most of the time that would be calculating slope. Occasionally, like in part B, we needed to find something, so we had to plug things in and find the y-intercept. And then sometimes, like in part A, we are already given all the information we need, so we just plug it in where it needs to go, and there's our answer. Okay. So here are two problems that I want you guys to practice. So I'm going to need Ms. Stokes to pause the video so you guys can practice these, and then move on. So if you guys have questions, you can ask her, or you can talk to each other. But try this for a second. Okay, moving on. We're going to talk about graphing lines. Graphing, we need two things. We need 2 points. Now, how we get those 2 points, I'm going to show you in the first and the second problem. There's 2 different ways to do that. This first one is the one that we're most familiar with. We start with the y-intercept. That's where it crosses the y-axis. So I would start right here. Then to find my second point that I need to draw a line, I would use my slope. The slope is rise over run, so this would be up 3, to the right 2. So I'd go up 3 squares, right 2. So that would be my new point. And I can just draw my line. And that's it. So I've got 2 points. But look at here with this one. I'm given the slope, that's negative 2. That would mean go down 2 to the right 1. But I'm not given the y-intercept. Well, that's okay. If you remember from point slope form, I can figure out what the point is going backwards. So notice here with the y1 part, it's minus y1. Y1 would have to be negative to make minus a negative turn into plus. So I know the y coordinate of my point is negative 3. And then this one's just straightforward. I would just plug in 1. So this is my point. Point 1, negative 3. I can plot that point and then use my slope, which again I said is negative 2. So I'd go down 2 to the right 1. So down 2, right 1. Down 2, right 1. You only need 2 points. You can do more if you want. But then I'm done. So then I can just draw my line. Okay. Now, if you don't remember how to do that with point slope form, you could, you could get this equation in y equals mx plus b. You could distribute the negative 2. and then subtract 3. Well, look here, my y-intercept is -1. Look where it crosses the y-axis. It crosses the y-axis at -1. So I end up with the same line, just two different ways to do it. So if it's easier for you to go ahead and rewrite your equation so it's in y equals mx plus b, feel free to do that. That's fine if you do. This one should take 2 seconds. So x equals 3. The x equals a number line is the vertical lines. So all I need to do is go on the x-axis where x equals 3 and draw a vertical line through that point, and I'm done. That's all I need to do. Okay? So same thing with the other practice. What I want you guys to do is to take these problems, pause the video, try them yourself. Hopefully it won't take you very long. You can talk with each other, you can work with each other, but then after a couple of minutes, go ahead and move on with the video. All right, something that we've talked about is parallel lines and how parallel lines have the same slope. We also talked about perpendicular lines having opposite reciprocal slopes, but here we have the same slope. Intersecting lines, their slopes have nothing in common. They're completely different. So for example, I had something like this. Y equals 5x plus 1, y equals 2x plus 3. So my slope there, 5 and 2, are completely different, so they're just going to cross. Coinciding lines, we didn't really use this word, but we had an example where we rewrote it into y equals mx plus b and then found that not only did they have the same slope, they had the same y-intercept. So here'd be an example. They're exactly the same. Now with all of these, the easiest way to determine which one of these three it is if we get the equation in y equals mx plus b first. This first one, if I look here, is already in y equals mx plus b, so I can compare the slopes. They are exactly the same, so they would be parallel. If I look at the next one, the first equation is in y equals mx plus b, but the second one is not. I want to get y by itself. I would subtract 6x from both sides. And then divide by -2. So I would get y equals -6 divided by -2 is +3. 10 divided by -2 is -5. If I look here, both the slopes and the y-intercepts are exactly the same, so this would be coinciding. So that's got to mean that this last one is just intersecting, but of course we've got to double check and make sure, because I've tricked you guys before and I've done ones where it actually wasn't the third example, so we just got to double check and make sure. Got to get y by itself, so I'd subtract 3x from both sides and have 2y equals -3x plus 7. Divide by 2. Get y equals -3 halves x plus 7 halves, which I could write as 3.5, or I could write as 7 halves. So there's one equation. Then I'll do the same thing with the other one. This one, all I have to do is divide by 3 and get y equals 4/3 x plus 7/3. Yep, there's nothing special about those two slopes. -3 halves and 4/3 have nothing in common, so these would be intersecting. Okay. All right. So again, continuing. Whoa. Okay. I guess no practice then. All right. I think this is actually the last page. Yep. This is the last page. So here's one where the instructions look really wordy and really complicated. There's typo here anyway. It's supposed to say and. Fix that. It says, given the equation of the line and point P not on the line, find the equation of a line parallel to the given line and a line perpendicular to the given line through the given point. Ugh, lots of words. All this is asking you to do is to take this equation, take this point, write the equation of the line that's parallel, and write the equation of the line that's perpendicular. If I use point slope form, this is really, really easy. And if you notice, they don't tell you whether to use point slope form or slope intercept. If I were you, I would use this form because you already know what x1 and y1 are. It comes from the point. All you need is the slope. Well, we've talked about this before. Parallel lines have the same slope. So in this case, it would be -2. So here's my first answer. Then I use same slope, and then x minus a -1 turns into +1. So that's my parallel line. Now perpendicular, hopefully you guys remember, we need to do two things. So for perpendicular, we want opposite. So that's talking about different signs, and then reciprocals. So that's talking about taking a fraction and flipping it. So the slope for the perpendicular line would be +1/2. So all that changes from my answer before to this answer is the slope 1/2. And I'm done. Okay? So again, if you use point slope form of a line, which I wrote for you right here, all you have to do is think about the slope itself, m, and then plug in the point for y1 and x1. Parallel, same slope. Perpendicular, opposite, we're talking about different signs. And reciprocal, flipping the fraction. Now let's take a look at this one. This one, my slope is not easy to find. It's not easy to see because it's not in y equals mx plus b. So here I've got to get y by itself first. So I'd have y equals -2 divided by -5 actually makes it +2/5. Now I know that's a really ugly y-intercept, but the nice thing about this is it doesn't matter. All I need from this equation is the slope. Because for the parallel line, I'll use the exact same slope. For the perpendicular line, I'll change the sign, I'll make it negative, and then use its reciprocal. So again, point slope form. I'll put 4 in for y1, 2/5 in for my slope, and x minus -2 turns into +2. So there's parallel. Then perpendicular, I would use the same thing, except I'm going to change the sign and flip it. And there we go. And that's it. Okay? So all we've talked about today is writing equations of lines in y equals mx plus b and slope intercept, which is slope intercept, and point slope form, which is what I just did these problems in. Also talked about graphing. Okay, so you practice these problems in graphing. We need 2 points, unless it's a vertical or horizontal line. Those are really easy. If they're in y equals mx plus b, y-intercept, slope. If they're in point slope form, you can figure out what the point is, start there, and then use the slope. Or like I said earlier, you can get it in y equals mx plus b, but perhaps you guys talked about this one. If you try and do it that way, it actually gives you a fraction y-intercept, which isn't very nice. So this one would be still easier to use the point, which in this case would be -2, 1. and then use the slope, negative 2/3 would be down 2 to the right 3. Because see, when I draw this line, it doesn't cross the y-axis at a nice location. Okay, it's in between 0 and 1. So that's why we get that fraction y-intercept. That's it. So here is your assignment. It is all from the textbook. Now I know some of you guys probably don't have your textbook with you, but you're going to need to share. Maybe some of you will need to go one at a time to your locker to get your textbook. But here it is. And also I'll have copies of this textbook page to give to Mrs. Stokes so that she can hand those out to people who don't have their textbooks with them today. Sorry I wasn't here, but hopefully you guys had a good day today, and I'll see you tomorrow. Bye.